All right, let's dive into something pretty cool. We're going to tackle a really fundamental question in AI today. How does it solve a problem when it's, well, completely blind? Think about it. Searching for a solution with no map, no hints, nothing. Just a starting point and a finish line. So how on earth does it work? Let's find out.
Okay, picture this. You've got an AI, and we just drop it at the entrance of this massive, sprawling maze. It knows it needs to find the exit, right? But it has no map, no compass, absolutely no clue which paths are just dead ends and which ones might get it closer to the goal. So, what does it do? How does it even begin to figure this out? This is the exact puzzle we're going to solve today, looking at the same strategies AIs use in these situations.
So before an AI can take even a single step, it needs something absolutely crucial, a super clear definition of the problem. I mean, you can't solve a puzzle if you don't even know the rules of the game, right? This whole process is the bedrock of AI problem solving, and it's all about laying out the puzzle pieces perfectly.
So what are those rules? Well, the AI essentially runs through a checklist. First up, the initial state. Okay, where am I starting? Then the actions. What moves can I actually make from here? The transition model is basically the what-if part. If I make this move, where will I end up? And of course, the goal test. This one's a big one. How do I even know when I've won? Then you've got the state space, which is just all the possible places it could ever be. And finally, the action cost. How much effort does each move take? Once the AI has answers to all of these, and only then, can the search really begin.
And this whole type of problem solving has a name, and it's perfect. It's called Uninformed Search, or even better, blind search. Because that's literally what it is. The AI has no idea if a move is getting it closer to the goal or further away. It's not getting any warmer or colder hints. It's just exploring. So the big question is, how do you explore systematically when you're completely in the dark? Well, it turns out there are two really famous ways to do it.
First up, let's meet strategy number 1, breadth-first search, or just BFS for short. I love the nickname for this one, the Patient Explorer, and it fits perfectly. This approach is super methodical, it's careful, and it absolutely will not rush ahead into the unknown. Its whole philosophy is explore wide before you explore deep. So what's its rule? It's simple. Expand the shallowest unexpanded node first. Now, what does that actually mean in plain English? It just means the AI looks at all of its immediate options, everything just one step away, before it even thinks about looking at things 2 steps away. The best way to picture it is like dropping a pebble in a pond. It explores that first ripple completely before it moves on to the next one, expanding outward.
And the secret sauce that makes this work is a really simple idea called a FIFO queue. It stands for first in, first out, and it works exactly like you'd think. It's just like waiting in line for a coffee. As the AI finds new places to go, it sends them to the back of the line. And it always serves the one who's been waiting at the front the longest. It's this fair, one-at-a-time process that guarantees it explores level by level, methodically.
Okay, let's actually see this in action. The Patient Explorer starts at the very beginning, node A.
And from there, it finds its immediate neighbors, B and C. Now, following that first in, first out rule, it's going to explore B and then explore C.
And it will absolutely refuse to dive any deeper. It will not look at what comes after B or C until this entire level is completely, totally checked off the list. That careful, step-by-step process is breadth-first search.
All right, now let's meet the complete opposite personality. Strategy number 2 is depth-first search, or DFS. And if BFS was the patient explorer, this one is the bold plunger. It's impulsive, it's aggressive, its motto is basically go deep or go home. It could not be more different from what we just saw.
And its guiding principle is, you guessed it, the exact opposite of BFS. Expand the deepest unexpanded node first. What this means is, as soon as it sees a path, it just commits. It picks one and follows that single path all the way to the very end, totally ignoring every other choice it could have made until it hits a wall and has to backtrack.
And the engine that powers this reckless dive is something called a LIFO stack. Last in, first out. The best way to think about this is a stack of plates. You add a new plate to the top, and you always take the top one off first. For our AI, this means the newest, most recently discovered path is always the very next one it's going to explore. It's all about what's fresh and on top.
So check out how the bold plunger does it. It starts at A, and just like before, it sees paths to B and C. But instead of exploring them both, it immediately picks one, let's say the one to B, and just dives right in.
And it keeps going, following that one single path deeper and deeper and deeper, all the way until it hits a dead end. It doesn't even think about that other option it saw earlier.
Only after it's completely exhausted a path does it backtrack to the last choice it made and then tries the other way. That poor node C won't get a look in until every single possibility down the B path has been tried and failed.
Okay, so now we've got our two contenders, the patient explorer versus the bold plunger. One goes wide, the other goes deep. So, which one's better? Well, like pretty much everything in AI, the answer is, it depends. It totally depends on the problem you're trying to solve. So let's put them head to head and see where they shine.
So let's break it down. You've got BFS, our patient explorer. It's so meticulous, checking level by level, that it is guaranteed to find the shortest path. No question. But there's a huge cost, memory. It has to remember every single place it's visited. Then you've got DFS, the bold plunger. It's lean, it's mean, it's super memory efficient because it only has to remember the one path it's currently on. But the risk? It might dive deep and find some crazy long winding path to the solution when a much shorter one was sitting right there at the beginning.
This chart really spells it out. Let's look at the properties. Is it complete? Meaning, will it always find an answer if one exists? For BFS? Yes. For DFS? Not always. It can get stuck in loops. Is it optimal? Will it find the best answer? Again, BFS gets a yes, as long as every step has the same cost. DFS? Nope. But here's the big one, space complexity. That's just a fancy term for how much memory it needs. And look at this. BFS is OB to the D. That's really bad. It explodes exponentially. But DFS, it's OBM. That is way better. It's so much lighter on memory. And honestly, that huge difference in memory is often the thing that makes you choose one over the other.
Okay, theory is one thing, but let's make this real. Remember that maze from the beginning? Let's go back to it and see what happens when we unleash our two explorers inside. This is where you'll really see the difference.
First, in goes DFS, the bold plunger. It picks a direction, say it goes down, and just commits. It follows that path relentlessly, twisting, turning, hitting dead ends, backtracking, and eventually, yep, it finds the exit at B. So success, right? It found a path. But I mean, just look at it. That thing's a mess. It's so long, so inefficient, it's definitely not the best way to get there.
But now, look what happens with BFS, the patient explorer. It starts at A and just expands outward in every direction, like those ripples in a pond. It's exploring a lot of the maze for sure. But the very second it touches the exit at B, we know something amazing. We know for a fact that it has found the absolute guaranteed shortest possible path. And that right there is its superpower, optimality.
So what's the bottom line here? It's all about making a choice, a trade-off. If you absolutely need the best solution, the shortest route, the cheapest option, and you've got plenty of memory to burn, BFS is your go-to. It's your hero. But if you're tight on memory and you just need to find any solution and fast, then DFS is your friend. Think of it this way. There's no single best algorithm for everything. The right tool always depends on the job you're trying to do.
So, we've seen how an AI can solve a puzzle even when it's completely blindfolded, just by being super systematic. But that leads to a really interesting question, doesn't it? What happens if we take the blindfold off? What if the AI had some hints, a little nudge in the right direction? What if it could make an educated guess about which path is probably better? Well, that changes the game completely. And that is a story for next time.